morning, everyone, and thank you for taking the time to attend our webinar today. If you're unable to hear or see the presentation at any point, please let us know by using the questions or chat facility on the webinar toolbar, and we will investigate for you straight away. So by way of an introduction to today, I'm Claire Tasker and I'm part of the account management team here at the Coal Authority. So today I'm going to be talking about Mangas. Over the last few months, as we've been delivering these webinars, we've been gathering feedback on the additional topics that people would like to get more details and information on. And one of the most popular topics has been Mangas. Your feedback has also assured us that the real-life case studies that we use really help to highlight the importance of the mining information within our reports. So we will continue to use that format with a real-life situation that concerned Mangas, describing how we dealt with the incident here at the Coal Authority. I will also go through the risks to health associated with mine gas and the different types of coal mine related gases, how we report on mine gas incidents, and how you can obtain more information. Please feel free to ask questions as we go through today using the webinar toolbar. And what we'll do is collate these during the month that we present the webinars and respond in a handy FAQ document. And that way everybody can benefit from the questions and the responses that come through during the month. I'll also supply you with my contact details at the end of the webinar so you can get in touch with any future questions or queries or feedback. Before we move on to today's agenda, let's start with a bit of a recap of last month's webinar topic, which was protecting the public from hidden risks. This covered a case study of an unrecorded coal mine shaft and explained why some mining features are unrecorded and how we update our information once these unknown risks come to light. If you missed this webinar, a recording can be found on our YouTube channel, the address for which is on the bottom right-hand corner of the screen, or can easily be found by searching for the Coal Authority using the search facility on YouTube. We are recording and storing all of our webinars on our YouTube channel, so do keep your eyes peeled for additional recordings over the coming weeks and months. So the agenda for today is as follows. As per our previous webinars, we're going to kick things off with a real-life case study, this time using an example of carbon dioxide mine gas at a residential property in Lanarkshire. We will then go through the mine gases, the individual coal mine gases, and why they present such a dangerous risk. We'll then look at how the risks shown in the case study would appear in the official CON29M report produced by the Coal Authority. And this covers the mine gas risk and also details of the overall mining situation at the case study property. I will then go through our specialist mine gas emission report that we offer and what this includes. I'll then summarise and provide details of the support available here at the Coal Authority if you should ever encounter a mine gas issue that's been reported within one of our products. Right, so let's get started with the case study. So the gas hazard we're going to look at happened in a residential property in a village near South Lanarkshire, and this occurred back in 2010. The problem was called into the Coal Authority's Public Safety and Subsidence team through our dedicated hazards hotline, which is operated on a 24/7 basis, and was reported by the landlord of a residential property. He suspected that the issue was caused by mine gas, as he was aware that there was a shaft next to the property and described vent pipes going up the side of the property. The Coal Authority's statutory responsibilities include responding to and managing coal mining related hazards, including Mangas, and this team has many years of experience of dealing with a variety of incidents caused by the legacy of coal mining. We also have specific mine gas experts in-house who have specialist knowledge on how to respond to, monitor and treat mine gas issues. And gas emissions are frequently reported to the Coal Authority from many different sources, including the general public, emergency services and local authorities. These gas emissions may occur for a variety of reasons. Gases may be caused as a result of coal mining activity, but we also receive reports of gas from other sources, including landfill sites, failure of piped gas supplies or accidental spillages of chemicals, which aren't our liability to remedy. Through our expertise, research and specialist monitoring of gas, we can ascertain whether the gas is a coal mining related issue. So what I'll do now is talk you through the events and actions from start to finish to show you how the Public Safety and Subsidence team handled this particular case. To start with, let's take a couple of steps back and see how the hazard first materialised and was reported. The landlord reported that the tenants living in his property were an elderly couple who had been suffering from various symptoms, including dizziness, drowsiness and difficulties with their breathing. These symptoms reduced when they stepped outside, which made them start to suspect that the issue was happening inside the property. The couple had also recently purchased a colour gas heater at the time, which was failing to light. The property affected was a detached bungalow within this mostly residential area. The property had recently been converted from commercial to residential use, although the building had originally been constructed in the 1960s. The landlord and the tenants were concerned because they were aware that there was a recorded shaft at the property and that ventilation pipes ran from the shaft into the open air. And so they contacted the Coal Authority via our emergency hazards hotline. And this is when we started to manage the situation. Upon notification of this possible gas hazard, and especially due to the physical symptoms that the tenants were experiencing, we mobilised our regional project manager straight away, and he arrived at the property on site within 2 hours of the report being received. Our network of regional project managers based on the coalfield help us to achieve these quick turnarounds for attendance and really demonstrates the importance that the Coal Authority place on public safety. Because of the nature of the hazard and the fact that mine gases can be particularly hazardous to health, the project manager was also supported by our regionally based contractors called Mines Rescue Service. They also have stations around the coalfield, mirroring the locations of our regional project managers. Mines Rescue also support us in providing the 24/7 hazards hotline and that frontline response to coal mining related hazards. Both the project manager and Mines Rescue Service are supported by our in-house project support team, who liaise with all parties to ensure their safe arrival on site and provide all the details surrounding the individual cases, such as stakeholder details, any background information and an overview of the mining situation. The objective of the Coal Authority's call-out response is to ensure that there is no risk to the health and safety of individuals or risk to property. When he arrived on site, the project manager used special gas monitoring units to take samples of gas, supported by Mines Rescue, and samples were taken both inside and outside the property, including the loft space. During the initial sweep of the property, no evidence of mine gas was found. Whenever we receive a report of a hazard that could potentially involve gas on the dedicated hazards hotline, Coal Authority operatives are trained to always advise that people living in the affected property immediately open windows in order to ventilate the property and reduce the risk to people's health and lives. So at the time of the monitoring in the property, the house had been well ventilated by these open windows. However, the gas monitors and some gas alarms were left in key areas throughout the property: the living room, hallway, kitchen and bedroom, and the monitors were set up to take readings 4 times an hour. The project manager went through the gas monitor and alarm setup with the residents and also discussed with the landlord, and this was supported by the 24/7 hazard service, and a duty officer would always be available at any point during the night should the alarms go off. So although there was not a gas issue apparent upon the initial visit, these measures reassured the stakeholders that their concerns were being dealt with by the Coal Authority. While the project manager and Mines Rescue were undertaking the gas monitoring on site, back at the Coal Authority's head office, project support experts in the Public Safety and Subsidence team were undertaking research into the mining situation and past history of the site and the surrounding area. Very early on in the investigations, and in line with the description of the landlord, it was clear that the property was located where there had been a previous mine gas issue reported to the Coal Authority. Research also revealed that the issue had been resolved at the time by installing 2 gas ventilation pipes. The pipes, or vent stacks, were installed to a recorded shaft also at the property, which had been treated by consultants on behalf of the Coal Authority in 1995. During these works, the upper section of the shaft had been drilled and then grouted to restrict any fugitive emissions coming from the shaft. A ventilation system had also been installed using the pipes attached to the side of the building, which vented the gas above the roof level. During these works, air bricks were installed to the building in question to make sure it remained well ventilated. At the time that these works were carried out in the mid-90s, the property in question had been a small industrial unit rather than a residential home, with people regularly coming and going from the premises, and the treatment was fit for purpose for a building of this type. When the gas issue was reported to us in 2010, the property had been recently changed from commercial to residential use. The next day, the project manager attended the property again to undertake further investigations. Our mine gas expert based in Nottinghamshire had also been mobilised to site and arrived on site the day after the issue had been reported. Our gas expert had gathered Met Office information that the atmospheric pressure had dropped. This meant that ground gas, such as mine gas, had a higher likelihood of rising to meet that gap that had been previously formed by air pressure gas pushing into the ground. And this meant that it was more likely for hazards and dangers associated with any coal mine gas to be more pronounced. The sampling carried out the next day detected increased amounts of carbon dioxide, and when readings of 3.5% of the air were taken, this resulted in evacuation of the property. For illustration purposes, carbon dioxide normally occurs at around a level of 0.03%, and at 5% can seriously affect respiration. Further investigations found hotspots in the property at levels as high as 11% carbon dioxide. So obviously we were very concerned about the health of the residents, especially as they were an elderly couple and more vulnerable to health risks. The project manager worked with the tenants and arranged for them to be moved into a local B&B, and the residents were happy to evacuate into alternative accommodation, and we supported them every step of the way. The Coal Authority also made contact with the Environmental Health Officer at the local authority to inform them of the situation. Now, going back to the research being undertaken back at the Coal Authority on the possible causes of the current gas situation. The subsequent conversion work to create a residential property from the original commercial building could have resulted in the air bricks that had been installed at the property at the time of the works done in the 1990s being either removed or covered by insulation, therefore reducing the ventilation to the property. Adjustments to services such as gas and water as a result of the conversion had also been introduced, which could have created additional pathways for gas to enter the property. These changes had been carried out without the Coal Authority's knowledge and was followed shortly after by the start of the health problems experienced by the residents in 2010. As part of our research, we also interrogated our unique database of mining information across the UK's coalfields. The mining history at the location was that the area had been extensively worked for coal, limestone and ironstone, and the village had grown around the coal mining industry. The recorded shaft that provided the problematic pathway for the carbon dioxide provided access into the 6-foot coal seam. Historic records showed the depth of the shaft at 49 metres deep, so relatively shallow, and the last recorded use was in the 1920s. However, due to the lack of records at the time that it was abandoned, the Coal Authority had no treatment details for the shaft. The location was also near a past open cast site which was established in the 1980s. During the open cast works, the operatives had introduced a pump well to lower the water levels in the area in order for them to extract coal more efficiently. This included the water level in the shaft at the property in question in the case study. When the open cast site was shut down and pumping in this well stopped, the water levels began to rise or recover. When water began to fill the old coal mine workings again, including the shaft in our case study property, the mine gas was being pushed through the old workings and up through the shaft, which again was relatively shallow. The works in the 1990s had alleviated the problem by venting the gas, but these were designed to be fit for purpose for an industrial unit, not a domestic house. The conversion of the property had also potentially caused additional problems by reducing ventilation and increasing the number of gas pathways into that property. The Coal Authority considered the options of what could be done at the property. One option involved installing a gas membrane to the property. Now, retrofitting a gas membrane is a risky option, as any small gap or hole or damage in the membrane would have made the membrane useless and dangerous, and any future modifications made to the property, including an extension, could also have affected the integrity of the membrane, leaving it susceptible to mine gas getting into the property. And this could have posed a very dangerous risk for the health of any occupants. The other option was to purchase and then demolish the property and to install a freestanding vent stack to the recorded shaft, protected by a palisade compound. This option would completely remove the risk to any vulnerable receptors in the future. Rather than attempt to block or repair the pathway from the source of the mine gas, it was decided that the safest way to deal with the issue was to remove the chance of the gas affecting anyone's health. So the residential property was demolished and works were undertaken to further secure the vents away from any further modification. The purchase of the property and demolition was seen as the safest proposal, although obviously this had to be managed carefully with the stakeholders involved, in particular with the landlord. The Coal Authority purchased the property from him and all legal costs were covered by us. In this case, the residents, after being housed in the local B&B for a week after the initial evacuation, were now happy to find alternative rental accommodation. We worked closely with service providers and specialist asbestos surveyors to ensure the safe demolition of the property. And this was a particularly challenging site as space was limited and as neighbouring properties were very close by. We worked with our framework of local contractors to investigate the exact location, size and treatment of the shaft that had been previously treated with the gas vents. All works that were carried out required a detailed gas risk assessment to be produced and signed off by our mine gas experts and health and safety team before works commenced on site. The Coal Authority's project manager also installed gas alarms to the properties next door while these works were taking place, and residents in these neighbouring properties were provided with precise details on what to do and how to contact the Coal Authority's public safety team if the alarms went off. The works included rerouting the existing pipework into new stacks and fitting the pipework with a gas monitoring point, which can be inspected by the Coal Authority as part of its inspection programme of liability sites. On completion of the works, the land was sold by the Coal Authority and was purchased by the neighbouring property owner. To ensure the future safety of the mine shaft and gas vent infrastructure, when we sold the land, we did so with a number of covenants preventing the further building on the site. The land is now used as an extended garden area and is available to be inspected by the Coal Authority to take gas measurements at the vent stack. We have made sure that the area in question is safe and that there is no further possibility of people suffering ill health as a result of the coal mine gas issue. So that concludes the case study for today. I hope you found that interesting, and please do let me know if you have any questions using the facility in the webinar toolbar. So what I'm going to do now is take you through the specific risks and hazards associated with mine gas. Mine gas occurs because the air within a coal mine is usually a mixture of atmospheric air, but with various pollutants. These are either generated naturally or as a result of the coal mining process itself. And this, combined with the confined space of a mine, means that pollutants can be present in dangerous levels and in some cases can even completely displace the air. For example, an excess of carbon dioxide can be encountered in the enclosed environment of an abandoned mine, and this occurs when coal, which is primarily made up of carbon, encounters the oxygen in the air or becomes oxidized. The Coal Authority's mine gas specialists manage these hazardous gases, such as methane, carbon dioxide, carbon monoxide, and hydrogen sulphide. Our expertise includes addressing issues and our unique knowledge in identifying, monitoring and remediating mine gas concerns. With the exception of hydrogen sulphide, which can have the odour of rotten eggs, these gases are colourless and odourless. Hydrogen sulphide and other trace gases may also be present, giving an emission a characteristic smell. But these smelly gases are usually only found in small concentrations, and they represent a nuisance rather than a risk to people's health. Because mine gas is generally odourless, this makes them so difficult to detect, and unfortunately they only usually get reported to the Coal Authority after physical symptoms have started to become apparent. Mine gas becomes a problem when the pathway from the source of the gas, so a mine featuring old workings where the coal has been oxidised, in the case of carbon dioxide, to receptor. So for example, in the case study, it was an elderly couple in the property. Any route to surface for mine gas can potentially cause an issue, including mine entries such as shafts or adits, geological faults, or fissures in the ground and shallow mine workings. Just to re-emphasise that the Coal Authority operates a 24 hours a day, 7 days a week response system for mine gas hazards. We respond to immediate mine gas hazards and monitor for mine gas issues, assess the risk and remediate all on an emergency basis. Our extensive knowledge of the behaviour of mine gases and their migration paths is used to monitor, predict and manage potential hazards. With over 700 gas monitoring points and over 200 mine gas vents throughout the UK coalfields, we have a unique understanding of mine gas and extensive data sets. We are experienced in installing remediation schemes, including active and passive ventilation systems. So the vent stack in the case study was passive with no fans required. The gas was left to dissipate into the air naturally. However, some of these stacks require electric fans to help get rid of the gas safely into the atmosphere. And these sites require the setup of an electricity kiosk, which require regular maintenance by the coal authority. Other remediation schemes can include installing gas membranes, other barriers, and mine gas collection schemes. Here we can see further details for each mine gas in particular. The exposure limits for each mine gas refers to what would be classed as adequate controls of exposure to a substance hazardous to health, such as a gas, under health and safety regulations, namely the Controllers Substances Hazardous to Health Regulations 2002, or COSH regulations for short. There are two variations. So the long-term limit is the maximum exposure over an 8-hour period, and the short-term limit, which is the maximum permitted over a 15-minute period. So I'll go through the characteristics of each gas and the physical symptoms that can result from exposure to those gases. So to start with, carbon dioxide was the gas featured in the case study and is colourless and odourless, but at high concentrations may produce kind of an acid taste. It also does not burn, which means that the gas appliances may fail to light if there are high concentrations in the air, such as the colour gas heater in the case study. To give examples of the physical effects, at 5% of the air, breathing difficulties can start to occur. At 7 to 10%, unconsciousness can result after a few minutes, and a high carbon dioxide concentration will eventually cause death. Turning now to methane, this is a colourless, odourless and flammable gas, which is explosive between 5.3% and 15% concentrations in the air. Methane is not toxic in itself, but can be dangerous at high concentrations, especially in confined spaces, as it will displace the oxygen in the air and cause breathing difficulties, unconsciousness or death by suffocation. Carbon monoxide is highly toxic. It is not normally present in the atmosphere, but can occur as a result of mine workings as a result of low temperature oxidization of coal. If breathed in, carbon monoxide binds to the hemoglobin in the blood and reduces the blood's oxygen carrying capacity. As with other toxic gases, the level and duration of exposure determines the severity of the effect. So, for example, at 400 parts per million, a headache develops after 2 to 3 hours of exposure. At 1600 parts per million, headache, dizziness and nausea will be present in around 20 minutes, and collapse and death in 2 hours. At 2 to 2.5 parts per million, unconsciousness will occur in about 30 minutes, and high concentrations may provide little or no warning before collapse. Even deafness has been reported after severe carbon monoxide intoxication. Moving to hydrogen sulphide, this is also colourless, but unlike the other mine gases we have looked at, has that odour of rotten eggs. The odour may be perceived at around 0.003 parts per million, but at higher concentrations, the odour may not be detected due to the gas's effects on the sense of smell. Hydrogen sulphide again is highly toxic and interferes with cellular metabolism. It does this by blocking the use of oxygen by the body cells, and therefore tissues and organs that require a lot of oxygen, for example the nervous system and heart, are particularly affected by this gas. You can see the exposure limits on screen, and as an illustration of what can happen where levels become more concentrated, at 30 parts per million, eye irritation can occur. At 50 to 150 parts per million, irritation of the eyes and respiratory tract, which can lead to nausea, vomiting and headaches occurs. At 250 to 600 parts per million, prolonged exposure commonly results in pulmonary edema or fluid on the lungs and also unconsciousness. and at 1,000 to 2,000 parts per million, unconsciousness, stopping of breathing, and death can also occur. As well as these physiological effects, hydrogen sulphide is also explosive. So now we've gone through the mine gases themselves and the associated risks in more detail. What I'm going to do now, using the case study location as an example, is go through an example of the Coal Authority's official CON29M report and run through the mining risks contained there to get an idea of the overall mining situation described in the report for that location. This will then lead into the additional information available specifically for mine gas incidents, so people can get more information on what's occurred. Here you can see the extract of the summary table for the CON29M, and this is for the case study property. The first yes response in the summary table relates to past underground coal mine workings, and you can see the detail from the main body of the report, and this relates to the recorded workings that are drawn from our industry-leading coal mining database. Here you can see that there are shallow workings in the area that could affect the property and deeper workings down to a depth of 40 metres. The last workings in the four seams that were worked in the area took place in 1900, which could have been accessed by the shaft in question that we mentioned in the case study, although given the shaft's latest recorded use was in 1921, the shaft could have also accessed workings further afield that would not be close enough to influence the surface area of the property in question. The next yes response relates to future underground workings. Although there are unlikely to be any future workings in the area, given the lack of licences granted by the Coal Authority or any other body in the past, no notices have been issued under the Subsidence Act 1991 to owners of nearby properties to say that their properties are likely to be affected by subsidence as a result of recent underground mining. However, as there are still reserves of coal present in the area, we would still draw people's attention to this potential risk related to those remaining reserves. The next section relates to mine entries, and here you can see the details of the mine entry that was recorded at the property and that required the mine gas ventilation system to be installed following the demolition of the property. Here you can see how our information gets updated following treatment to recorded mine entries. Moving now to the mine gas section, this is the statement that you would see highlighted on screen again. If mine gas is flagged in this way on the CON29M, it is highly likely to be one of our monitoring sites, or what we refer to as a liability site, that controls and monitors gases, just like that mentioned in the case study. So what if you or your client would like further information on the mine gas issue at a particular location or property? You can see on screen that a mine gas emission report appears in the further recommended reports in the table at the bottom of the official CON29M summary page, suggesting that this follow-on report is purchased. It is this follow-on report that the Coal Authority offers in order to provide further details on the specific mine gas hazard and how the Coal Authority has dealt with the issues using its specific mine gas expertise and framework of contractors. As the case study incident was reported via our Public Safety and Subsidence team and we undertook treatment works as a result, this would also be highlighted as a yes response in the summary table under hazards related to coal mining. So let's go back to that mine gas emission report that was recommended at the bottom of the summary table. So what information is available? If you purchase a mine gas emission report as a result of the recommendation in the CON29M summary, you would expect to see extensive details of any works carried out in relation to the mine gas emission. For example, informing you whether a venting station or other remediation scheme has been built to manage any ongoing emissions. The location of the site will be shown on a plan, complete with any pictures where appropriate. And you'll also get any details around the various gases which have been recorded at the site, including copies of any graphs showing the monitored levels over a certain period of time. The mine gas emission report is written by one of our in-house mine gas specialists here at the Coal Authority, using the information that we have available for the site to provide real peace of mind to clients on the actual steps that have been taken to remedy the mine gas issue at that particular location. Here is a summary of the key facts of the report. If you use your original CON29M reference number, your transaction is fast-tracked with the system automatically recalling the geography used for the original report. As this is a tailored pack of information put together by our in-house mine gas experts, they can take up to 5 working days to supply. Both reports, so both the official CON29M and the mine gas emission report, are available via our online ordering platform at groundstability.com. We have a range of different reports to suit your needs, more than just the CON29M report, and these address specific mining risks as well as the mine gas emission report. Equally, if you have any questions about any of the reports or you're unsure about which one you really need for the situation or property in question, please feel free to contact our team of specialists within the mining reports team at the Coal Authority, and they'll happily take the time to talk you through everything that you have questions about, queries about, or want more information on. So please feel free to give us a call. Okay, so that concludes our webinar for today. I hope you've all enjoyed listening and have found the content interesting. If so, please keep your eyes peeled for further updates and webinars from the Coal Authority in the near future. There will be a survey which pops up after the webinar is finished, and I really encourage you to pass us any feedback on the content, the delivery of the webinar, and any topics you'd like to see in future webinars from us here at the Coal Authority. As I said at the beginning, the mine gas topic was suggested in that feedback, so we really are conscious that we want to push out the topics that will appeal to people and people need more information on. So please feel free to give us that feedback. The survey will also be emailed out after the webinar if you'd like a bit more time to reflect, so that should be coming out tomorrow. And as I mentioned at the start, we've been gathering any questions throughout today's webinar, and we'll look to supply these with responses in the handy FAQ document, which we'll distribute when all the webinars have been completed for this month. If you have any other questions or comments and would like to contact me direct, my contact details can be found on screen now, and a recording of a version of this webinar will be made available on our YouTube channel. So I'd just like to say thank you so much again for taking the time to attend. Hope you enjoyed it. Please get in touch and have a great afternoon. Okay, goodbye. Thank you.